Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. Welcome to our online class of Polymers School. Today I will discuss about a very important part of chapter 11, which is polymers and polymerization. Polymer chemistry is a very important branch of chemistry, actually organic applied chemistry. Many useful articles are prepared from these polymers and we can give an example such as plastic. Plastic is the plastics, artificial fibers, etc. are widely used for our daily purposes and which is manufactured in industry on a large scale. And today these polymers and polymerization will be discussed in our today's class. Okay, then what is polymerization? The reaction, it's a chemical reaction, the chemical reaction in which innumerable tiny molecules joined together, linked together and form a large molecule with a large molecular weight is called polymerization reaction. That means polymers are a large molecule and they are organic molecules. They are large organic molecules and they are made from tiny molecules and numerous tiny molecules. That means a lots of number. Polymer, the word polymer means, poly means lots or many and mers means units. If the tiny molecule is A, then they are linked such like that. Several. Continue. The chain is continued for lots of times. Okay. This time they repeated by 2000 times, or it may be 20,000 times and so on. Then if the monomer unit is like that, A and B, two portion, then they are linked up like this. Okay, and they form a large molecule. So this is the polymerization reaction and polymers. If only two monomers link together and form a molecule, we call this molecule dimer. If three monomer molecules join together and form a molecule, then we call this product is trimer. Okay, then poly times, several times. That's why we call polymers. Polymer. Okay, these polymers can be classified into different ways, and at first we have to know according to their structure or manufacturing process. They can be divided into two types. They are of two types. One, addition polymers, and another is condensation polymers. Addition polymers and condensation polymers. What is addition polymers? Or what is, and addition polymers are produced by addition polymerization. That's why what we know about, we have to know about what is addition polymerization. It's a chemical reaction, the chemical reaction in which the monomer units are joined together, directly joined together without losing any part of it. That means without losing any atom from it, and form a large chain molecule. Form a large chain molecule is known the addition polymerization, and the product is produced is known polymer, addition polymer. Okay student, is it clear? The reaction in which, the polymerization reaction in which monomer molecules are joined together or connected together without losing any part of it, any atom of it, and form a large molecule is called addition polymerization. Okay, then we take example. Okay, example will be discussed here. We can take ethene, and for that generally alkenes and their derivatives. Alkenes and their derivatives are used as a monomer for this type reactions. Okay, then we can take where he used monomer is ethene. CH2 double bond CH2, ethene molecule, and this is the monomer, and after polymerization it produces polymer, and the name of this polymer is polythene. That means with monomer, before the name of monomer we have to add poly, and we get the name of polymer, polythene. If we take propene, then we get polypropene. If we take vinyl chloride, then we get polyvinyl chloride, like that. Okay, then at first ethene molecule. This ethene molecule, in presence of very high temperature and high pressure, and in the presence of a catalyst, a little amount of oxygen, produce polythene by polymerization reaction, by addition polymerization reaction. And how the reaction occurs, let's see. At first, the catalyst is initiated the reactions. The catalysts are initiated the polymerization reaction at first, and the reactive part of this monomer is double bond. At first, catalyst attacks the double bond, and this double bond breaks, and a free hand on each carbon atom arises. Each carbon atom, a free hand arises. Then single bond, carbon in middle, we have to draw single bond. Then CH2, and on this carbon free hand, free hands at the two ends. Okay, two free hands are coming out from two ends. Okay, two free hand coming out, that means two bonds are coming out from this unit, and then we have to put a third bracket and put a small n as a subscript. Okay, and this is the polymer unit. This is the polymer. This is the way to represent a polymer. This n can be varied. It may be 2000 or 20,000, and on this number the strength, the density, the durability of polymer depends. Okay, then look at this. This will have to be clear to you. In the middle, single bond, two more double bonds coming from this unit, and then we have to put third bracket with this small n, and this n, that means this unit, these two ends, mainly these two ends outside from the inside, means this unit repeats lots of time, and these lots of time will be mentioned here as n. Okay, and we have to know it can be varied. Okay, And then this is the polythene. This is the polythene. That means how they are linked. They are linked like that. CH2. This. Another adjacent molecule like that. They are come close, then attached. Then another here come and attached. That means this is the monomer unit. They linked up together lots of time and produce a addition product. And I have already said that condition is a very important, very high pressure. 3 conditions have to apply for any polymerization reaction. 1 is very high temperature, 2 is very high pressure, and a catalyst. Okay. And then for preparation of polythene, we have to apply 1000 atm pressure. 1000 atm pressure, very high pressure, and the temperature will be 200 degrees Celsius, and a little amount oxygen or organic peroxide used as a catalyst. Organic peroxide and titanium chloride, titanium oxide, that means transition elements, chloride, oxide, they are used as catalyst. Mainly organic peroxides are used for polymerization reaction. Organic peroxide means, we know peroxide is this. Organic peroxide. The chemical formula of organic peroxide, R is the alkyl radical, and this is the peroxide group. O, single bond O and 2 bond free. This is the peroxide. Peroxide. The amount of oxygen is slightly large. Okay. These peroxides are used as a catalyst for these polymerization reactions. Okay. Then this was the preparation of polythene. We have to learn about some more examples. Now we have to prepare polypropylene. Polypropylene. From this name, we can easily say that what will be the monomer. Propene. For polypropylene, the monomer will be propene. But we know propene has 3 carbon in their chain. That's why it's propene. And this is. Okay. This is propene. Propene, 1 carbon-carbon, double bond. For our reaction, we can write this like this. Okay. Hydrogen here, hydrogen, and this carbon here. Okay. I erase this. This is propene. This is our propene, and we have to need N monomer unit, N monomer molecules, and then we get, and the polypropylene is produced at 140 atm pressure, 120 degrees centigrade temperature, and in the presence of titanium chloride, titanium tetrachloride, okay. This is the catalyst. And then double bond breaks. At first double bond breaks, middle carbon-carbon single bond, CH2, one hand and one hand free here, and third bracket N. This is polypropene. This is polypropene. For balancing, this N goes with this. N monomer molecules linked together and form polypropene. N propene molecule linked together and form polypropene. Here you must have to show that. Okay, comes from inside to outside to single bond. That means this propene unit, this unit repeats for several times, for n times. Okay. This was the preparation of polypropene. Another example is very important, which is PVC. Now we have to discuss about PVC. Another addition polymer. PVC means polyvinyl chloride. Okay, widely used polymer. PVC. We have heard about PVC pipe. It's a hard plastic. Okay, then and used for prepare rope, pipes, water pipes, and etc. Okay, and for this we need vinyl chloride. Here vinyl chloride is the monomer. Okay, here vinyl chloride is the monomer and polymer is polyvinyl chloride. Which is vinyl chloride? At first we have to know that this is vinyl group. This is called vinyl group. Okay, vinyl group, like functional group. And how this is produced? From ethene, one hydrogen is removed. From ethene, one hydrogen is removed and produce a monovalent vinyl group. And this vinyl group with a chloride molecule, ion, produce a chlorine atom, produce vinyl chloride. This is the monomer vinyl chloride. This is the monomer for this reaction. Similarly, for our better understanding, we can write it like that: chloride and hydrogen. Okay. Then polymerization. For this also the condition is high temperature, high pressure, and here organic peroxide is the catalyst. In presence of organic peroxide, number of N vinyl chloride group join together and form polyvinyl. CH2 single bond, C bond, chloride, and here hydrogen, and here N, small n. This is polyvinyl chloride. Okay, I think the addition polymerization is completely clear to you. Okay, now we have to discuss about condensation, another type of polymerization, which is condensation polymerization. Condensation polymerization is the polymerization in which the monomer molecules join together and form a large molecule by eliminating a simple molecule from it. That means from monomer molecules, a simple small molecule is removed, such as a simple molecule. These simple molecules can be water molecule or carbon dioxide or methanol. water molecule, or carbon dioxide, or a small molecule methanol, okay, methyl alcohol. These types of small molecules will be removed, will be eliminated from the monomer units, and then they are linked up and form a large molecules with a large molecular weight, and this is called condensation polymer. And for condensation polymerization, the monomers can be two different molecules, okay, two different compounds molecule, and can be same molecules also. In condensation polymerization, with polymer product, a simple molecule or a small molecule is produced. Nylon 66 is an example of condensation polymerization. It's a very important polymer. It is widely used for preparing artificial cloths, robes and toothbrushes, etc. Okay, then this nylon 66 is a polymer which is prepared by condensation polymerization. And for preparing nylon 66, we take nylon 66, we take two different monomer molecules. That means nylon 66 is prepared from two different monomer molecules. One is adipic acid and another is hexamethylene diamine. Hexamethylene diamine. Names are very important and new for you. So, student, observe carefully. Okay, adipic acid. So look at this structure. Here you can see this is a 4. Okay, and this group is methylene. Methylene group, 2 hand free. This methylene group, tetra for 4, tetramethylene dioic acid. And in this structure 6 carbon atoms are present in their chain. In their carbon chain 6 carbon atoms are present. That's why the chemical name of adipic acid is tetramethylene hexadioic acid. Okay, then this another monomer is also a 6 carbon containing organic compound, and this is also you can see in this also 2 amino groups are present. That means 2 same functional group are present, and it's an important characteristics for condensation polymerization monomer. Generally they have 2 functional group in their molecule. They have 2 functional group in their molecule. Here 2 methylene amino group, 2 amino group. This is a functional group. This group is known as amino group, and this is methylene group, and this is carboxylic group. In adipic acid, 2 carboxylic group is present at 2 ends, and in hexamethylene, hexa for 6, carbon chain 6, and diamine, 2 amino group. That's why hexamethylene diamine, in hexamethylene diamine also 2 amino groups are present. This is the monomer molecules. I think it is clear. Now, here condensation polymerization occurs, and we have know already in condensation polymerization one simple small molecule have to removed from the monomer units. Okay, and here water molecule is removed from these 2 monomer molecule. From these 2 monomer molecule, one water molecule is eliminated. Okay, then how is happened? See, let's see. From carboxylic group, from one carboxylic group here OH, and from this amino group one hydrogen. Hydrogen is removed by water molecule as a water molecule. Okay, H from methyl amino group to one hydrogen, and this one hydrogen goes with OH from carboxylic group. Okay, then he eliminated as a water molecule and they link together. Okay, now CO, you can see this portion. This group also a important functional group for organic chemistry. Okay, this is called amide group. This is known as amide group. Okay, CO, NH, 2 bond free. 2 bond free. This is called divalent functional group, amide group. Okay, now this product is a amide. That's why this will be a amide product. Okay, now these two monomer linked up, joined up and produce this. This was the step 1. Now real polymerization starts from there. This is the monomer for this second step. This is the monomer for the second step. In that case, here also N, number of N, this amide molecule links together and form this. How? Another monomer unit comes to close this molecule, and from this OH and another monomer units from hydrogen linked together and removed, and from this part another amide group come and from carboxylic end come together to it, and then OH, H removed from this side, and then in that case one bond is free and free up, and from this side this bond will be open, and we have to put third bracket to represent monomer unit, repeating unit, and we put N here, N, small n, which means a lot of molecules, lot of repeating unit. This number may be 2000 or 20,000 and so on. Something else also. And in that case, look, for first step, one water molecule remove. And if we take n number of adipic acid, we take n number of hexamethylene diamine, then we get n number of this amide molecule. And this monomer unit then here form actual nylon 6,6 by repeating several times, a large scale. Okay, and then always in condensation reaction 2n minus 1 water is removed from this process. For n number monomer, always 2n minus 1 number water molecules will be removed. Is it clear, students? You will have to practice it. Okay, it's a very important question for your exam. Okay, at first I recap. At first we have to need two different monomer units, monomer molecules. Then these two monomer molecules join together and form a amide compound, a new compound. Which this is step 1. Then the step 2. Step 2, this amide molecule, this amide compound joined together on a large scale and produce nylon 6,6, and a small molecule water is here produced with this polymer. According to the sources, polymers can be divided into another two types. One is natural polymer and another is synthetic polymer. One is natural polymer and another is synthetic polymer. Natural polymers are produced in nature. Naturally, they are found naturally. And example, starch, carbohydrates, which are the polymer of glucose. Okay, we have known about this glucose. This is a source of energy for our for any animal body or plant body, living body. This glucose is linked together and form carbohydrates and starch. And another which is natural polymer, and another natural polymer is protein. Protein is very important for our for any living body, for their growth. These proteins are the polymer of amino acids. That means amino acids are the monomer of protein, and glucose is the glucose C6H6O6, C6H12O6. Okay, this is the glucose. This is the monomer of carbohydrate and starch. And another amino acid, there are several types of amino acids and they have different structure. They have some complicated structure. That's why this is not included in your syllabus. You will be learn about that in HSC level. And I just say amino acid contains at a time NH amino group and COOH group. That means in amino acid molecules, carboxylic group is present as well as along with it amino group also present. This amino acid is the monomer unit of protein. This protein, starch, cellulose, carbohydrate, these are the examples of natural polymer. And another is synthetic polymer, also artificially. They are produced or manufactured in industry artificially. Is known as synthetic polymer, and widely known synthetic polymer is plastics. But there are some disadvantages of using plastics also, and with which these disadvantages are very severe disadvantages. Plastics are non-biodegradable compound. Plastics are non-biodegradable compounds. That means plastics are neither decomposed by bacteria, any types of bacteria, nor react with any types of other substances. Okay, that's why when we put the plastics here and there on soil, they cannot, they remains the same for a very long time, and that's why our environment get polluted. Sometimes we try to burn plastic and try to melt them to prepare new plastic products, but this is very dangerous very hazardous for our health and for our environment, because when plastics are burned, then many toxic gases are produced, which is very harmful for our environment and our health. That's why we have to recycle the plastics. And that's all for today, students. Assalamu alaikum.